Using this knowledge, Boyer and other colleague Robert Healing tried to create rDNA and insert it inside E. coli. They would accomplish this by using the E. coli enzyme to open up E. coli. When they conducted the experiment, the DNA broke into 5 fragments instead of 1. Later that year, in 1972, Boyer and Cohen both met at Hawaii during a conference about plasmids. In 1976, they engineered plasmid-containing genes for tetracycline resistance. It was inserted inside E. coli to create a bacterium resistant to tetracycline. The plasmid would be isolated at Cohen's lab and then be sent to Boyer's lab to be cut with E. coli to analyze the DNA fragments, which would then be sent to Cohen's lab again to be joined and inserted inside E. coli and replicated, which created new recombinant plasmid, which were isolated and analyzed. Paulberg, Herbert, W. B. Boyer, and Stanley S. Cohen findings gave way to advancement in biotechnology, which would later allow for chimerics to exist. Paulberg won the Nobel Prize in 1980 for his research and contribution to the understanding and creation of recombinant DNA.
Chimeric plasmids were first created in 1976 by David A. Jackson, along with other colleagues at the Department of Microbiology at the University of Michigan Medical School. The construction involved the use of hallucinogenic factor EI from col-EI DNA as a replicon. Chimeric DNA was created with the use of DNA of 3 other parental species other than col-EI. Along with this, E. coli DNA fragments containing galactose or tryptophan operons were used. E. coli strains included the K12 strain, E. coli W3110, as well as strain DB866 for its XDV Gal120B fragment carrying the galactose operon, and another for its 080PT-A-E fragment containing the tryptophan operon. The galactose and tryptophan operon fragments were created from an unfractionated restriction endonuclease EcoR1 digest of DNA taken from E. coli. To form attachments between the fragments, T4 polynucleotide ligase, which was incubated for 4 hours at 16 degrees, was used. Plasmid PCC1 was constructed with coli EI and fragments containing galactose operons. Plasmid PCC2 was constructed with col-EI and fragments containing tryptophan operons. Plasmid PCC3 was constructed with col-EI and fragments containing galactose operons and fragments containing tryptophan operons.